My name is Sander and I'm a big fan of coffee, cocoa and the climate. And since you're watching, I'm going to bet that you're too. When you're like us, you love talking about the products we love and how they can benefit all the people in the supply chain while remaining within our planetary boundaries. This is the Carblecast. Let's dig in. The first time that I heard about biochar must have been around 5 years ago. And the way that I understood biochar was that it would use waste streams from coffee or cocoa farms, such as dead wood or coffee cherries, parchment or cocoa pods, burn them in the absence of oxygen, and then bury the charcoal underground in the coffee farms. And since all this biomass had grown from carbon dioxide that was captured from the atmosphere, this would then be a carbon removal, and the carbon would be removed for centuries since charcoal isn't reactive. But admittedly, I knew very little about biochar. So when somebody in our comment section asked me to do an episode about it, I decided to call Kathleen Draper. Kathleen is the chairperson from the International Biochar Initiative, and she was happy to tell us more.
All right, welcome, Kathleen. It's a pleasure to have you here. First question, could you tell us a little bit about when you first heard of biochar and how biochar became such a focal point of your work?
Sure, and thank you for the invitation. I stumbled across biochar more than a dozen years ago when I was doing a master's in managing for sustainability and looking for a thesis topic. And this was one of the only technologies that I actually understood because I grew up on a farm and it made sense to me. And I somewhat naively decided to dive in. Well beyond writing a thesis, I joined the industry about 12 years ago.
Very cool. And can you maybe explain to us in a nutshell, what is biochar and how is it used in coffee and cocoa farms?
So I like to describe biochar as burnt toast. You're taking any kind of organic material, putting it in an oven that doesn't have much, if any, oxygen, turning the temperature up. And what you get out is something that's not very appetizing. It's this black substance. You've burned off all the water and most of the volatiles, and you get this structure that is unappetizing for soil microbes, much as burnt toast is unappetizing for humans. But when you put it in the soil, it does a number of things. And I'm oversimplifying here because there's many different types of biochar, but it can help with things like water holding capacity, reducing nutrient leaching. And what most people are most interested in these days is you have preserved up to half of the carbon that was absorbed during the plant's lifetime into a very long-lasting carbon. So that's why it's considered a carbon dioxide removal strategy.
And you mentioned raw materials there. In the case of coffee and cocoa, what kind of raw materials are we talking about?
So I published a paper on this topic several years ago, and it was fascinating to me that about 98% or more of what is harvested can end up as biochar. So everything from the coffee pulp, the chaff, the parchment, the spent coffee grounds, and even the tree prunings or stumpings can all be turned into biochar. And in the cacao industry, it's mostly the pods, and it could also be tree prunings as well.
And you were describing an oven with very little oxygen in its environment. How does it look? What kind of ovens are typically being used, and where in the entire value chain does the production of biochar take place?
It can take place throughout the value chain. So I've been teaching coffee farmers in Colombia how to make biochar with their tree stumps with very, very low tech, low cost, sometimes no cost equipment. It's as simple sometimes as building a cone in your soils, as long as you don't have sandy soils. And at the upper end, we have companies that have industrial scale pyrolysis or gasification that's able to convert the residues at the milling level. And I've been talking to companies that are looking at carbonizing the chaff combined with the spent coffee grounds to create a biochar product.
You were mentioning the smallholders in Colombia that they made a cone in their soil. What does that really mean, a cone in the soil?
Literally, you're digging a cone, and then how that works is you start the fire at the bottom with some very dry materials, and then as it starts to ash over, you layer on more material. So what's happening is the flame's going up, and oxygen is prevented from going below that flame cap level, and that's how it turns into biochar instead of ash. It's very counterintuitive, but it's probably how many indigenous communities developed the terra preta soils, most commonly known in the Amazon, but it had been found throughout the world.
So does this mean that the practice of producing biochar is already maybe millennia old?
It has been found in China, throughout Latin America, Africa, even in Europe. They found anthropogenic soils that have charcoal made by humans. So
fascinating.
Yeah.
And the production of the biochar itself, does that emit any carbon dioxide? Because of course we're burning materials.
It mostly emits carbon monoxide. But as I said, only half of the carbon absorbed into the plant is preserved. We have learned that some of these low-tech methods, you really need a dry biomass, or you could have methane emissions. So those are the things that you would need to teach smallholder farmers. Also, when you're putting out the fire, you can either do it through a water quench or what they call a snuffing process. And it's important to really understand the implications of emissions when you're water quenching it. It's better to put the water on the sides as opposed to dumping it right in the middle of the fire, because that does cause some methane emissions, which we don't want.
And in the absence of biochar production, what would typically be done with these byproducts of coffee and cocoa farming?
It depends. It's very variable. I know at least in Colombia, the coffee stumps, maybe 20% of it is used for cooking, and the rest of it just is, left to rot. The coffee pulp is often composted. One really good thing to do with your biochar is to co-compost it. That'll help prevent nutrient leaching. It speeds up the actual composting process. It heats the pile hotter. So there's a lot of different things that are happening with these different feedstocks, and I don't think you need to carbonize it all. It just depends on what the current practice is and what might be a better process from an emissions perspective and reduction of the need for fertilizers, things like that.
And you mentioned that it's possible to produce biochar at a small scale level at the farms or at an industrial level. What are the pros and cons of both approaches?
So in places like Colombia, my experience is that it would be very challenging to get the biomass to a centralized location. The roads are challenging. I just don't see that makes a lot of sense in many scenarios. On the other hand, where you have a centralized mill and you have the residues there, it makes complete sense to have your higher technologies there, because you can produce not only biochar, but in some cases, renewable energy in the form of either heat or electricity. That doesn't really happen at the farm level. You really are only going to get biochar.
Makes total sense, since in different countries, at least the countries that I visited, we have different processing systems. Either the farmers do some of the pulping or the processing, or indeed they deliver cherries to a centralized washing station. So that makes total sense to me. If we talk about the farmers, what's in it for them? What's the business case?
That's a very good question. Lately, in the last 2 or 3 years, there's now an incentive to convert their residues into biochar in the form of carbon removal credits. There's a methodology called the Artisan C-Sync methodology, owned by Carbon Standards International, a Swiss company, that is paying smallholder farmers that use their own biomass and use the biochar on farm. It's not life-changing money, but it is an incentive to, change their practices. What I've found is farmers, at least in Latin America, seem more interested in this biochar combination with coffee pulp or even the milling effluent water to reduce the amount of fertilizer they need to purchase. That seems to have much larger financial implications than the revenue from the carbon credits.
So would it be fair to say then that there are three potential benefits of biochar, one being higher yields, two being lower cost of inputs, and three being potential premiums for carbon credits?
Yes.
And do we know per hectare how much carbon can be removed in this way?
Ooh. A lot of that depends on the number of trees. So in a shaded coffee plantation, you're going to have a lot more biomass available than you would in some of these other ones. We did some calculations back a few years ago. I just don't remember what they are. It might be 1 to 2 tons of biochar per hectare.
Mm-hmm. And the biochar is almost completely carbon then?
Again, that depends on which biomass you're using and how hot the temperatures are, but it's probably from the trees, the prunings, 80% or more carbon.
What kind of prices do we typically see on the voluntary carbon market for biochar?
So for biochar-based carbon removal credits right now, the average is about $180 per ton of CO2.
Wow.
And when you convert that into dry tons of biochar, it's twice that amount. So it's significant. What we're seeing now is that the biochar industry, the production capacity is scaling fast because there are a lot of people looking at that saying, oh, I want to be in this business. We don't have as many buyers of those credits as we need to support scaling right now. So I'm hoping the price goes down a bit. People don't want to hear that, but in order to have buyers, we need it to be affordable.
And do we typically see that the payments are made by the same companies who buy the coffee or the cocoa that's produced by these farms, or are they sold as offset outside of the value chain?
I don't know the answer to that. I don't have visibility into the buyers. I don't think it's happening. I suspect it's not happening. I would love for it to happen, but the big buyers of biochar right now tend to be high-tech companies. Microsoft, Spotify, yeah.
And you mentioned scaling. At what scale is biochar currently being used?
I would say the demand for the biochar itself is one of our barriers to scaling. We have a lot of work to do on educating farmers of all sizes about the benefits of using biochar. Right now in the US anyway, the biggest buyers seem to be the compost industry because it can solve some of their problems. In other areas, we're seeing it being used in building materials, such as concrete and asphalt. That presents a huge market. And in other areas, we're seeing it used in a more urban context for tree planting and stormwater management, things like that.
Two things. First of all, you mentioned that biochar is not only applied back at the farms where the coffee or cocoa is grown, but it's also sold as biochar outside of the value chain. I wasn't aware of that.
Here's my biochar wall. Can you see that?
There's some contrasting light.
Oh, sorry. It's black, so it's hard to see.
Yeah, indeed. And what is the main reason you build a biochar wall in your house?
Well, there are some performance issues that are interesting in terms of moderating humidity and electromagnetic shielding. But for me, it was just several people have done it before me. I'm not the originator of that. And I just wanted to see how the process worked, what it looks like, things like that. But I also have been working on different projects to put it in drywall and bricks. And we're about to have a test done in my hometown with using it in asphalt and things like that. It's a huge potential market for the volume of biochar that's coming online these days. So I think we need to think expansively, not just about agriculture, but where it can displace things that come from the fossil fuel industry, which I think is showing a lot of promise.
So it's better to remove the biochar off farm and use different applications to it than burying it in the farm and using it to fertilize the plantations.
I would say if the farm has a need, if they have some growing constraints that biochar can solve, that should definitely be the first place that it's used. There may come a point when that farmer has saturated the soils with biochar and it's no longer beneficial to keep adding biochar, but I am a firm believer that agriculture should be a principal use in this scenario.
You mentioned that a farmer can produce 1 or 2 tons of biochar per year. At what level does the soil become fully saturated with the biochar?
I think that really is soil dependent. You know, we know from all the tens of thousands of peer-reviewed papers that biochar works best in depleted soils in Africa and places like that. We're seeing the tropics are losing a lot of nutrients because of heavy rains and things like that. So you could go years, 5 years of microdosing biochar, first in nurseries and then in the tree plantings and then, you know, around water bodies and things like that. So it could be years, depending on what your soils are and what your growing constraints are, before you would want to start looking elsewhere for markets.
I was looking at this from a removals perspective, but maybe the impact on a reduction perspective, so by reducing the dependence on synthetic fertilizers, is actually much larger then, and that's where we can have the biggest impact on the carbon footprint of the coffee and cocoa industry.
Yeah, and I also think it's a good adaptation tool. You know, we're finding soils eroding. It can also moderate the temperature of the soils. So in certain farming situations, that's a good thing too. So it's a pretty versatile tool. The one caveat I would say is that, again, all biochars look the same, but they're very different from a physical, chemical, electromagnetic perspective. So it's important to not gloss over and pretend that every biochar can serve every purpose.
You already mentioned that the limited demand outside of the value chain is one of the barriers to scale up biochar. What kind of scale do you think we need to work towards in the coffee and cocoa industry, and what barriers do we still face?
Well, obviously, there's millions of coffee farmers. But what's been interesting is with this artisan C-sync methodology, which is still only 2 or 3 years old, tens of thousands of farmers have already been trained on this in Africa and India, not as much in Latin America as I would like to see. So there are programs and organizations out there that are not industry specific. So I think it would be really useful to see some industry specific training, which is not just how do you make biochar, but what are the best uses on these kind of coffee farms for that biochar, a sort of prioritization, planning and education that is more industry specific. And I would also love to see if there is a way for the industry to support those credits, as well as scaling out this program to educate the farmers on how to make and use biochar.
And what is next for you and the organization that you're leading?
Well, I have been the board chair of the International Biochar Initiative for the past 4 years, but my reign is over at the end of this year, and I am going to be working on a few different things. I'm most interested right now in working either at a national level or at a corporate level to develop biochar decarbonization plans. So what that might look like is company X is in the food and beverage industry, and they have 5 different crops in 40 different countries. What does the biochar decarbonization plan look like for that entity? Where do we look first? Is it smallholders? Is it mills? How can we eke out the best, the highest number of emissions using which technologies, things like that. So that's what I'm looking at.
Amazing. Well, thanks so much, Kathleen. We will definitely keep following you. Thank you for taking the time to explain biochar to us.
My pleasure.
I really enjoyed my conversation with Kathleen, and she definitely changed my perspective. I always thought that the value of biochar would be in using it as a tool for carbon removal by storing carbon underground. But instead, I realized that biochar may have a much bigger impact in reducing farmers' dependence on synthetic fertilizers. Synthetic fertilizers typically account for roughly 20% of the total carbon footprint of a bag of coffee. So this could be huge. Despite the high premiums that biochar carbon credits fetch on the voluntary carbon market, I don't think the voluntary carbon market will be the best mechanism to finance the use of biochar. The reason here being that we need to reach planetary net zero in 2050, meaning that we have to reduce emissions in all different sectors, and we cannot use removals or emission reductions from one sector to compensate for the emissions from another sector. So I think there's definitely space for companies and NGOs working in coffee and cocoa value chains to promote biochar and to maybe train farmers in the application of it. Anyway, that's my perspective, but of course I would love to hear yours. So feel free to comment below. You can find us on LinkedIn or at carble.co.